Hello and welcome to another quick maths tutorial. In today's video I'm going to be going over how to convert between radians and degrees, because as you go further into maths you may start to notice that you don't always have to or should be using degrees as your angles in, for example, trigonometric functions, especially in calculus and other topics too. And so you may see people use radians because it is a bit more of a natural way of measuring angles, since 360 degrees was arbitrarily chosen, to be around the point, because Babylonians like doing maths in base 6, whereas radians are a bit more natural. We'll talk about why that is very soon. So first, let's think of a circle. And the key property of a circle is it has a radius from any point towards its origin, its center. And so what happens is we can create like a wedge shape which has two radii as going to the edge of the circle, and this creates an arc length. This arc length is subtended by an angle. We're going to call this theta, and I'm going to tell you straight away that when the arc length is equal to the radius, so all three sides of this wedge are radius size, this makes theta 1 radian, or this angle is defined as 1 radian. This is what a radian essentially is. So if you may remember the arc length formula, it's essentially the same for the whole circumference of the circle, but the proportion that the arc length is out of the full circle, so it's only a fraction of the full circumference. It's the same as the proportion that the angle it subtends by, theta, is out of the full 360 degrees, because we're going to try and figure out what 1 radian is in degrees. So we have theta over 360, that's its proportion, times 2 pi r. So I've left everything in the radii here, so we can start to cancel later. So in this case, the arc length we defined as the radius, so we can put r equal to theta over 360 times 2 pi r. And here we can just have another look at the definition of what theta is. It's 1 radian. It's very important that you get the arc length here is the same as the radius, so that is dependent on how big the circle is. But theta is always going to be the same amount in degrees. So if we rearrange this for theta, we can divide both sides by r and get 1 is equal to theta over 360 times 2 pi. And then we can rearrange a bit more to get theta by itself, in which we get it's 180 over pi degrees exactly, which is roughly 57.3 degrees. So that's 1 radian. And if we can sort of backtrack here to get what 360 degrees would be, you'd understand that that's actually 2 pi radians, because a full revolution is 2 pi radians around the point. And essentially that's how you go in between. You times radians by 57.3 to get it into degrees, and you do the inverse and divide by that same amount to get back into degrees. So that's how you convert between the two. And make sure you understand which, for whatever you're doing in maths, which angle is best for you to use. It's a bit nicer when in terms of exact values or in terms of pi, because lots of classic angles like 180, 90 will be pi amounts of radians. So that could be a little bit nicer when you're doing a bit more pure maths. So I hope this tutorial helped, and thanks for watching.